All right, looking at number 54, they're trying to get you guys to understand why the quotient rule is necessary. So they're trying to talk to you guys about the basic mistake that people want to make right here, that if you're trying to take the derivative after the fact of a division expression, f divided by g, that you can't simply take the derivative of the top divided by the derivative of the bottom. So let's talk about why that is. So this left side, let me underline this in blue here, guys. So maybe put another way, f over g prime would basically be, let me do this in a little more formal notation, they're asking you now to take the derivative with respect to x of the numerator function f of x divided by the denominator function g of x. And to kind of steer you in the right direction, this isn't really necessary, but I think you guys would be a little lost without it. They told you in these problems to let f of x and g of x be the same function, and a very simple function at that, just x. So that means, guys, that what we're really doing here in blue is taking the derivative with respect to x of f of x is equal to x. So that's my numerator. And my denominator, g of x, is equal to x as well. Well, every one of you is going to look at that and say, well, wait a minute, that's a little weird. X divided by x is just 1. And 1 is a constant. And when we go to take the derivative of a constant, we always end up with 0. So in this expression right over here, guys, this left side we came up with here is equal to 0. Interesting. Let me switch colors now. I'm going to go purple. And in purple, I want to talk about this right side over here. What they're asking you to do there, f prime divided by g prime. Again, a slightly different way of writing that would be, all right, that's going to be f prime of x in the numerator and then g prime of x in the denominator. And again, we're going to remember, guys, that in the example or the case they've told us to consider, f of x and g of x are both equal to just plain x. So f of x then, everybody, the derivative of x is 1. And in the denominator, g prime of x, the derivative of x, is 1 as well. And of course, 1 divided by 1 is equal to 1. So in blue here, everybody, that 0 was the value of the left side of this expression, and this 1 in purple is the value of the right side of the expression. So you could make the argument here now, guys, that since, okay, Captain Obvious, 0 is not equal to 1, then we can conclude here that, I guess let's write this out formally, f over g prime, the derivative of a quotient, is not equal to simply the derivative of the numerator divided by the derivative of the denominator. Technically, guys, all we've done here is we've shown that that isn't the case if f of x is equal to g of x, and they're both equal to x, and you are welcome to spend some of your valuable free time trying this with different functions, but I think you'll get the point here, guys. So they're just trying you to come up with one example, and really, once you've shown one example where it doesn't work, you know that it's not a rule that works all the time. So there we go, guys. That's number 54.